I am Bhagyalaxmi from Marri Institute of Technology and Management, Assistant Professor of Department of Chemistry. Today, I am going to discuss about Module 1, Water and its treatments. From that water and its treatments, it's a very important topic we discussed in the previous sessions. It's like hardness of water, EDTA method. Then types of hardness of water and what is the main concept of EDTA method, how we have to find out the hardness with the help of EDTA method or complexometric method. Then today's session we will go to discuss about potable water. So what is potable water? The water which is suitable for the drinking purpose is called as potable water. Means it does not presence of any type of impurities. Then only it will be help to the drinking purpose. So water we are called as potable water. Then what type of the specifications or characteristics will be present in our potable water? So these are all the specifications and characteristics. If it is a presence in this potable water, then only that water can be utilized to this domestical and also the drinking purpose. So hence we are called as potable water. So what type of the specifications will be present in this potable water? So this water should be clear, colorless and odorless. The optimum hardness is equal to 125 ppm. The pH of the water is equal to 7 to 8.5 and there is a recommended maximum concentration of the TDS, total dissolved solids in the potable water should not exceed 500 ppm. The turbidity should not exceed 25 ppm. And the water must be free from the pathogenic bacteria. Means it should not contains pathogenic bacteria or harmful bacteria like algae, fungus or different type of the virus organisms, microorganisms. If it is a presence this type of the pathogenic bacteria in this water it is not suitable for this our drinking water. So the water must be free from this again the heavy metals and their hydroxides. Heavy metals like iron, manganese, plumbum, tin, lead. So these type of the metal if it is present in our water, so such type of water it is also not suitable for the drinking purpose. Then it is free from this dissolved gases. It's like hydrogen sulfide, carbon dioxide and ammonia and other dissolved gases are also not present in this our potable water. So these are all the specifications or characteristics present in our potable water. So the water which is suitable for this our drinking purpose. So first what are the steps are involved in the treatment of potable water? Means before going to this potable water steps, first we need to use the sources of water. So sources of water means it's like rainwater, river water, lake water, ocean water. So many sources will be there. So that's based on the place, based on the area. Then we have to take in this our sources of the water. In these sources of the water, if it is any impurities is there or any bacteria is there or any metals is there, then we have to eliminate or we have to treat it with the using of treatment methods. Then that water can be utilized to this our domestical and also the industrial purpose. So here the next topic we have to discuss about steps are involved in the treatment of potable water. So what are the steps are involved in this our potable water? Then here the steps will be there. First one is the screening process, aeration process, sedimentation process, filtration process, disinfectation process, storage and distribution. So these are all the steps will be involved in this our treatment of the potable water. Then here you have to observe this, this is the image. This is the image of this our potable water steps. So first sources of water. We need to take in this our sources of the water from our resources. And then we have to take into this our first one, the screening, aeration. After that we have to go to do this our sedimentation process. After that, filtration process and storage and distributed to this our houses or in our homes through this pipeline. So this is the image we observe that our treatment of this our drinking water or treatment of this our potable water, they are this our steps. Then next, here it is in this first one is screening process. So in these steps will be, we have to eliminate all the impurities like colloidal impurities and suspended impurities, pathogenic bacteria and metals, oxides, or also all the impurities can be, we have to eliminate by this using of the different treatment methods. So in these steps are involved in this our treatment of the potable water. There is a step one is the screening process. So what is mean by screening? So screening means which is presence of the screeners. So large number of holes in it. The water can be passed through this large number of holes in it. Then this number of holes will be there. So whenever we have to fastly through this our holes, then bulk or any large particles or floating impurities can be eliminated by this our screening process. So here we have to observe this image. There is a number of holes will be there. So we have to pass it through this our water into this. Then here it is in this like sanitary items, plastic bottles, plastic caps, or also this bulk or large number of impurities, bulk impurities, heavy impurities can be like wood pieces or leaves or heavier objects, materials or floating impurities. All this impurities or materials can be, we have to eliminate or we have to purified, okay, by this our screening process. So this is the step one, screening process, which is consist of the number of holes in it. When the passed through the water, then removal of floating impurities from this our screening process. Then go to this aeration process. Then the water, above the water can be passed through this or subjected to the aeration process. So in this aeration process, reacted with the oxygen, passing through the oxygen means air, air means oxygen, O2. Then exchanges of the gases, ion exchanges process will be there. Then exchanges of these gases with water and air, then increasing the oxygen content, then removal of impurities. Then what are the impurities can be eliminated by this our aeration process means like metals and their hydroxides can be eliminated by this our aeration process. So in this aeration process like iron, manganese, lead, tin are also there. Iron hydroxide, manganese hydroxides, lead hydroxides can be removed from this our aeration process. Okay, so this is our step 2. From step 1, we eliminated floating impurities. Step 2, eliminated this our metals and their hydroxides. Then again, the third step, we will continue the third step, sedimentation process. So in this sedimentation process, above the filtered water can be again passed through this our sedimentation process or sedimentation tank. Subjected to this our process only. So in this sedimentation process, we are using this our sedimentation tank. So this is we are called as sedimentation tank. So in this sedimentation tank, which is consist of the, so this is the sedimentation tank, which is consist of the paddle stirrers. So rotating of the paddle stirrers, and mainly the basic principle involved in this our sedimentation process is slow velocity. When passing this our water into this sedimentation tank, then that speed will be the slow. Okay, so slowly that hard water is passed through this our sedimentation tank. Then this paddle stirrers can be rotated. Okay, rotated, then the reactions will be takes place. So what is the procedure will be takes place, or what is the process will be going in this our sedimentation process? That is we have to discuss. So what is the sedimentation process? So in the sedimentation process, allowed to this our 2 to 6 hours stand by this process without any disturbances. Then in this sedimentation process, removal of colloids and also the suspended impurities. So like Zyle type of or precipitation type of the impurities, we have to eliminate it or we have to remove by this our sedimentation process. So what is the procedure? What is the process will be takes place in this our sedimentation process? Here it is in this mainly we are using this coagulants. So what type of the coagulants we need to use in this our sedimentation process, like soda alum or potassium alum. Alum means K2SO4 and Al2SO4 taken twice 24H2. It's like either sodium or potassium. So this alum, either sodium or potassium alums can be interacted with this our hard water of the hardness causing salts. So mainly this coagulant or alum can be which is helps to the attraction of the impurities. Then attraction of the impurities will be takes place. When it is that attraction will be takes place, then gelatin precipitations will be formed. This gelatin type of the precipitation is called as flock. Okay, it is also called as flock. So that is the reason again this sedimentation process, it is also called as a flocculation process. So by this flocculation we need to eliminate or we are eliminated of this our colloids and suspended impurities. So in this our flocculation or sedimentation process, our alum can be attracts to the impurities. Then accumulation of this our colloidal particles, as a result our settling down of this our settling of these colloidal particles in this our sedimentation tank at the downside. So these type of the white precipitation, okay, these type of the white precipitation or colloidal particles can be, it is nothing but sludge particles or precipitation or also nothing but colloidal particles. So these type of the particles eliminated by this our sedimentation process. So here it is in the sedimentation process. Mainly why we are using the sedimentation process means eliminated of the colloidal particles, elimination of the colloids and also the suspended impurities. This is the main role or main aim or main importance of this our sedimentation process. Then in this sedimentation process, our colloids or sludge or white precipitation of the impurities can be eliminated. So half of this session of this our filtration will be done by this our sedimentation process. Then again above the water means already filtered that water by the screening, eliminated the floating impurities, by the aeration, elimination of the metals, and by this our sedimentation process, removal of colloids and suspended impurities. Almost all the particles, impurities particles can be eliminated by these all the three treatment methods. Then here this filtered water, again we have to subject it to this or we have to follow this one more treatment method is filtration process. So in this filtration process, we are using of this mainly removal of colloids and suspended impurities. But here it is in the sedimentation process also we have to eliminate of these our colloids and suspended impurities. But not by the all the impurities can be eliminated by the sedimentation process. Hence we are going to this one more treatment method, that is our filtration process. So not accurately or not 100% of these our colloids and suspended impurities can be eliminated by this our sedimentation process only. So we are using one more process for this elimination of these impurities or suspended and colloidal impurities. We are using this process is the filtration process. So in this filtration process we are using two types of the filtration tanks. One is slow sand filtration tank and second one rapid sand filtration tank. Either you are using or we have to utilizing this slow sand filtration tank or rapid sand filtration tank. Then what is the difference of these two tanks? Here it is in this our rapid filtration tank, we passing this air compression air. So whenever we have to passing to this our compression air, all the impurities can be settled one layer to other layer to other layer. Immediately all the impurities can be eliminated by this our rapid sand filtration tank. But in this our slow sand filtration tank, there is no need to utilizing of this our compression air. Then whenever we have to passing the hard water, so one layer to second layer to third layer, it's slowly the removal of this all the impurities by this our slow sand filtration tank. Either utilizing the both the tanks or any whatever we have the sources, then we have to utilize it for this our filtration process. So if it is in this our filtration tank, in the filtration tank, here it is in this mainly the two types of the filtration layers is there. So three types of the filtration layers is there. One is fine sand layer and coarse sand layer, and the third one is a gravel sand layer. So they are the three types of the layers will be there. So fine sand layer, in this all the fine particles will be present, and the second one is some little bit of this our mainly the coarse sand layer. This is here we are called as a fine sand layer, and this is we are called as a coarse sand layer, and followed by this our sand filtration tank, which is consist of the gravel sand layer. That means here it is in this our mainly the three types of the layers is there in this our filtration tank. Three types of the layers is there, either in the slow or in the rapid filtration tank. So in the filtration tank, there are the three types of the layers will be there. One is the fine sand layer, coarse sand layer, gravel sand layer. They are the three types of the layers. So when the hard water is passed through this our first fine sand layer, then some of the impurities can be eliminated. Then again the water can be followed to the second layer. Again, so here it is in this second layer, then go to the third layer. The water can be passed through the third layer. So first layer to second layer to third layer, the water can be filtered one layer to second layer to third layer. Then all the impurities like suspended impurities and colloidal impurities can be eliminated by this our filtration process. That means in the filtration process, almost all the colloids and suspended impurities can be eliminated. Then go to this one more step for this our treatment method, disinfectation of the water by the sterilization process. So disinfectation, what is meant by disinfectation? So here it is in this the process which is utilized to kill the bacteria from this water is called as disinfectation process. So we are using any substance or any chemical agent for this process, or in this our disinfectation process for this elimination of this or kill the bacteria from this water. So the substance or chemical agent we are called as disinfectant. So in this process we are using the disinfectant. The disinfectant, whenever we are using this disinfectant, kill the bacteria from this our water. So this process we are called as a disinfectation process. Here it is in the disinfectation process, destroying or elimination or kill the bacteria. Harmful pathogenic bacteria is nothing but sterilization, or also called as disinfectation process. So in this sterilization or disinfectation process, it has so many methods is there. So first one is the boiling process, second one ozonization process or chlorination process. So depending upon this our impurities or bacteria, then we have to utilize these three types of the methods. So first, what is mean by boiling? The water can be boiled for the 15 to 20 minutes. In this 15 to 20 minutes, we have to boil that water. Then some of the impurities can be eliminated, but not all the pathogenic bacteria can be not destroyed by this our boiling process. So this water, it is utilized to the municipalities or also the sterilization process or the domestical purpose. Then need to, we are using of either the ozonization or by this our chlorination process. Then go to one more process is this our ozonization process. So what is mean by ozonization process? So in this ozonization process, here it is in this, we have to use this ozone, passing the ozone. Ozone, it is an unstable isotope. So it is unstable. So it's splitted into this O2 plus nascent oxygen. So this is we are called as nascent oxygen. So when the water is utilized to for this our treatment method, when passing this our ozone gas into this our water, this ozone, it is unstable, so it will be decomposed to form this O2 plus our concentration of the oxygen. Okay, concentration of this our oxygen. This is we are called as nascent oxygen. So this nascent oxygen, it is a very powerful disinfectant. It is a very powerful oxidizing agent. Then only this our disinfection process will be takes place. So when the formation of this nascent oxygen, only the disinfection process will be takes place. Why? Because this nascent oxygen, it is a very powerful oxidizing agent or disinfecting agent. This is only this interacted with the bacteria and destroy this bacteria from this water. So this is the process we are called as ozonization process. So ozone, it is a readily absorbed unstable isotope. So it is readily absorbed of this our by this our water only. Okay. Then after that chlorination process. So in this process, adding of chlorine to this water, then kill the bacteria from this water is called as chlorination process. So here it is in the chlorination, there are the such type of chlorinating agents will be there. It's like chlorine gas, Cl2 gas, and chloramine and bleaching powder. So these are all are the chlorinating agents. So first of all, by addition of this our chlorine gas, Cl2 gas. So this chlorine gas, it is a very good disinfecting agent which is absorbed this our water and which can be bubble in this water. In this process, amount of chlorine passed through this water to destroy this or harmful bacteria from this water or pathogenic bacteria, or it's like algae type of the bacteria, microorganisms can be eliminated or can be destroyed by this our chlorination process. So this method we are also known as chlorination process, and this chlorine can be reacted with this water. It generates or it creates or it forms the hypochlorous acid. Okay, hypochlorous acid. And after that also that it's formed this our nascent oxygen. So we know already this nascent oxygen, it is a very powerful disinfectant and also the oxidizing agent. So here it is in this oxidizing agent which is helps to this destroy this all the bacteria from this our water only. Okay, then here this chlorine, when the passing of this chlorine gas into this our water, it can be treated and also the generated of this our hypochlorous acid. So HOCl. HOCl, it is called as a hypochlorous acid to produce a HCl, and this is a very important. This hypochlorous acid, it is a very powerful disinfectant. And also nothing but it is also this oxidizing agent. So this is very powerful hypochlorous acid disinfectant. It is reacted with this our all the harmful bacteria, then the destroy will be there. So destruction of this our all the germs from this our chlorination process, then kill the bacteria by this powerful oxidizing agent. This is we are called as one of the method of chlorination process. Then one more, by addition of the chloramine. So what is the chloramine formula? ClNH2. This is we are called as chloramine. So when this chlorine interacted, first how we are getting of this our chloramine? So when the chlorine is interacted with this ammonia or mixed with the ammonia with the ratio of the 2:1. Okay, so here it is in the 2:1 ratio. Then combination of these two to get or to produce the chloramine. So this chloramine, whenever we should add it to this our water, then this water can be interacted this our chloramine, or chloramine is interacted this water, then the reaction will be takes place to produce the ammonia gas and HOCl. So you know it's a hypochlorous acid. So hypochlorous acid, it is a very powerful oxidizing agent. It is a disinfectant agent. And this HOCl again interacted means destroyed or also decomposed to produce a HCl and a nascent oxygen. This is also, you know, this is a powerful disinfectant. Then this our chlorination process will be takes place, means this all the bacteria can be, or all the germs can be destroyed from this our chlorination process with the help of this our chloramine. So what is the chloramine? Cl NH2, it is our chloramine. By the addition of chloramine to kill the bacteria from this water is called as chlorination process. Then one more, we have to utilize it to the bleaching powder. So what is the bleaching powder formula? CaOCl2, calcium oxychloride. So this calcium oxychloride, whenever it will be reacted with this water to produce the calcium hydroxide and also the Cl2. Again the Cl2 can be interacted with this our water to produce the HOCl and HCl. Again HOCl, it will be destroyed, means decomposed to produce this HCl and also this nascent oxygen. So this is also that nascent oxygen oxidizing agent. Then this our chlorination process will be takes place, means kill the bacteria from this water will be there. So this is also one type of the method for this our chlorination process with the help of bleaching powder, calcium oxychloride, CaOCl2. This is the formula of the bleaching powder. With the help of bleaching powder, destroy the bacteria or kill the bacteria from this water. So this is one of the method for the chlorination process. Then go to this last point or last topic or last step in our potable water steps, breakpoint chlorination. So what is mean by breakpoint chlorination? It is a controlled process. It is a controlled manner only, then we have to utilize it to this our chlorination process. So before only we know that chlorination process. So what is the chlorination? By passing the chlorine to the water, then destroy the germs or bacteria from that water is nothing but chlorination process. But here it is in this breakpoint chlorination, suitable amount, means the particular amount will be required for this our chlorination process. So this particular amount of this our required amount of the chlorine is added to the water, then this our disinfection process will be takes place in order to kill the bacteria from this our water. When this chlorine can be, the required amount of the chlorine can be added to this water, then oxidization will be takes place. Then this oxidized to enter this our organic matter and the reactions takes place. When it is reacted with this our free ammonia and chlorine, then the disinfection process will be, it will be that helpful to that. Then this breakpoint chlorination, which is determines the chlorine it is further added or not. By this chlorination, we have to elimination of these our organic matters, bacteria, and also this bad taste, bad odor, and also some of the excess of the chlorine into this water, chloroorganic compounds in this water, excess of the ammonia in this water. So all can be, we have to eliminate it. We have to remove from this our breakpoint chlorination process. Residual chlorine, if it is present in this, we have to eliminate. Okay, in this process only. So this is called as breakpoint chlorination. The point at which, what is meant by breakpoint chlorination? The point at which free residual chlorine is began to appear, it terms as the breakpoint. So here it is in this, we need to use the chlorine. By this residual chlorine can be appeared in this, so hence we are called as the breakpoint chlorination process. So here this we should add this the required amount of this chlorine added in this. By this x-axis we need to use and how much residual chlorine will be there, that is in this our y-axis. So if it is A grams of the chlorine, B grams of the chlorine, C grams of the chlorine, D grams of the chlorine. So what is the type of the eliminated impurities can be there? That is, we need to see, we need to observe in this our breakpoint chlorination process. So we are observed in this our mainly this our image, okay, image of the breakpoint chlorination process. If it is A grams of the chlorine will be there, so chlorine destruction of the compounds will be, we have to see or observe in this A grams of the chlorine, then again eliminated. If it is the B grams of the chlorine can be there, okay, so B grams of the chlorine can be there, then chloramine organs or again this any chlorine organic compounds will be there, then we have to eliminate. Or if it is the C grams of the chlorine can be there, then these any particle destroyed colloidal particles will be present in this, then we have to eliminate. And if it is the D grams of the chlorine will be added to this our process or added to this our water, then free available residual formation of the chlorine organism contents and also the any bacteria can be eliminated. Free ammonia residuals are also we have to eliminated by this our breakpoint chlorination process. So this is the last step for this. Our steps are involved in this our treatment of potable water. So step 1 is the screening process, step 2 the aeration process, step 3 sedimentation process, step 4 disinfectation process, and step 5 again breakpoint chlorination. So these are all the steps we need to use, and we have to eliminate all the impurities from that water, and we will get this our drinking water, means potable water. After this water we have to storage and distribute it to this our homes. So here it is in this our homes through this our pipelines into our homes. So this is the process we observed in this treatment of potable water. In this method we used, there are the different type of the or different of the sources of the water, means based on this our area only or sources of the water only we need to use the treatment methods. So this is our references used in this our steps are involved in this our treatment of this potable water. These are my references. I used this topic in this our topic only. So thank you all of you, thank you. And next session I'm going to explain about boiler troubles. So what are the boiler troubles and what is mean by sludge, what is mean by scale, and how the sludge will be formed, and what are the disadvantages, and how the sludges can be avoided with the using of these our methods, and also the scales, what is mean by scale and how the formation of the scale, and what are the disadvantages of the scales, and also how this removal of the scales from this our water. So these are all the topics we will explain, we will discuss in the next session. So thank you all of you.